Phase identification traces are used to identify each phase in a three-phase system. The device you are referring to is likely a phase identification tracer. The transmitter device injects a high-frequency signal onto the voltage at the zero crossing point of each phase. The signal is superimposed onto the phase voltage waveform. A handheld receiver meter detects the injected signal and identifies the phase being sensed. Applications include, firstly, identifying phases in energized and in-service large power systems, secondly, verifying phase connections during electrical maintenance or troubleshooting, and thirdly, checking phase rotation or synchronization. While HiPoth offers an older device that requires deenergization, modern phase identification traces are available that can be used on energized systems. Some examples include the Fuke 360 phase rotation tester, the Mega MIT 310 phase identifier, and the Ampro PRM1 phase rotation meter. These devices typically use a non-contact inductive coupling mechanism to detect the phase signals, ensuring safety and convenience. In electrical engineering, a three-phase system is a type of polyphase system used to generate, transmit, and distribute alternating current electrical power. It is the most common type of electrical system used by electrical grids worldwide to power most industrial loads. A three-phase system is more economical than other types of electrical systems because it uses less conductor material to transmit the same amount of electrical power. In a three-phase system, three conductors carry alternating currents of the same frequency and voltage amplitude, but with a phase difference of 120 degrees electrical. This means that the currents in the three conductors reach their peak values at different times, with a time difference of 1/3 of a cycle. The voltages between the conductors are also phase shifted by 120 degrees electrical. The three-phase system has several advantages over single-phase systems, which are commonly used in residential applications. Firstly, three-phase systems can deliver more power for a given conductor size. This is because the currents in the three conductors are balanced, which reduces the amount of current flowing in the neutral conductor. Secondly, three-phase motors are more efficient and have higher starting torque than single-phase motors. This is because the rotating magnetic field in a three-phase motor is more uniform, which results in smoother and more efficient operation. Thirdly, three-phase systems are more resistant to voltage fluctuations. This is because the voltages in the three phases are balanced, which helps to stabilize the voltage at the load. Phase identification is the process of determining the correct phase sequence of a three-phase system. This is important for several reasons. Firstly, incorrect phase sequence can cause motors to run in the wrong direction. Secondly, incorrect phase sequence can cause equipment damage. Thirdly, incorrect phase sequence can cause safety hazards. There are several methods for identifying the phase sequence of a three-phase system. One method is to use a phase sequence indicator. A phase sequence indicator is a device that detects the phase sequence of a three-phase system and displays the result on a meter or display screen. Another method is to use a voltmeter and an ammeter. This method involves measuring the voltage and current in each phase of the system and then calculating the phase angle between the voltage and current. The phase angle can then be used to determine the phase sequence. A phase identification tracer is a device that is used to identify the phase of a conductor in an energized three-phase system. The device injects a high-frequency signal onto the voltage at the zero crossing point of each phase. The signal is superimposed onto the phase voltage waveform. A handheld receiver meter detects the injected signal and identifies the phase being sensed. Phase identification tracers are used in a variety of applications, including firstly, identifying phases in energized and in-service large power systems, secondly, verifying phase connections during electrical maintenance or troubleshooting, and thirdly, checking phase rotation or synchronization. When using a phase identification tracer, it is important to follow all safety precautions. Firstly, wear appropriate personal protective equipment, including safety glasses, gloves, and insulated shoes. Secondly, ensure that the system is properly grounded. Thirdly, never touch any exposed conductors. Fourthly, follow the manufacturer's instructions for the specific phase identification tracer that you are using. Some common problems that can occur when using a phase identification tracer include: firstly, the device may not be able to detect the signal if the system is not properly grounded. Secondly, the device may not be able to detect the signal if the conductors are too far apart. Thirdly, the device may not be able to detect the signal if there is too much noise in the system. Fourthly, the device may not be able to detect the signal if the battery is low. If you are having problems using a phase identification tracer, consult the manufacturer's instructions or contact a qualified electrician. Here are some additional tips for using a phase identification tracer. Firstly, use a phase identification tracer that is designed for the specific voltage and current levels of the system that you are testing. Secondly, use a phase identification tracer that is certified by a reputable testing laboratory. Thirdly, calibrate the phase identification tracer regularly. Fourthly, store the phase identification tracer in a safe and dry place. Phase rotation is the order in which the three phases of a three-phase power system reach their peak voltages. The phase rotation is typically designated as either a BC or a CB. The correct phase rotation is essential for the proper operation of three-phase motors and other equipment. If the phase rotation is incorrect, the motor will run in the wrong direction or the equipment may be damaged. There are several ways to determine the phase rotation of a three-phase power system. One way is to use a phase rotation meter. A phase rotation meter is a device that indicates the phase rotation of a three-phase power system. Another way to determine the phase rotation is to use a voltmeter and an oscilloscope. The voltmeter is used to measure the voltage of each phase. The oscilloscope is used to display the waveforms of the three phases. The phase rotation can be determined by observing the order in which the waveforms reach their peak voltages. Phase sequence indicators and phase rotation meters are essential tools for electrical technicians and engineers who work with three-phase power systems. These devices can help to ensure the safe and efficient operation of electrical equipment. Electrical safety is paramount when working with energized electrical systems. Always adhere to established safety procedures and use appropriate personal protective equipment. Consulting with qualified electrical professionals is recommended for complex or unfamiliar tasks. The information provided here is for general knowledge and informational purposes only, and does not constitute professional advice. It is essential to consult with qualified professionals for specific applications and to ensure compliance with all applicable safety standards and regulations. Modern phase identification tracers offer several advantages over older devices that require deenergization. Firstly, they eliminate the need to shut down power to the system, which can save time and money. Secondly, they reduce the risk of electrical shock. Thirdly, they can be used on a wider range of systems, including those that are difficult or impossible to deenergize. The Fluke 360 phase rotation tester is a handheld device that can be used to determine the phase rotation of a three-phase power system. It is easy to use and provides accurate results. The Mega Mighty 310 phase identifier is a more advanced device that can be used to identify the phase of a conductor in an energized three-phase system. It is also easy to use and provide accurate results. The Amprop PRM1 phase rotation meter is another handheld device that can be used to determine the phase rotation of a three-phase power system. It is a cost-effective option for basic phase rotation testing. In addition to the devices listed above, there are many other phase identification tracers and phase rotation meters available on the market. When choosing a device, it is important to consider the specific needs of the application. Some factors to consider include: firstly, the voltage and current levels of the system; secondly, the accuracy required; thirdly, the ease of use; and fourthly, the cost. Phase identification tracers and phase rotation meters are essential tools for electrical technicians and engineers who work with three-phase power systems. These devices can help to ensure the safe and efficient operation of electrical equipment. Always follow proper safety procedures when working with electrical systems. This includes wearing appropriate personal protective equipment such as safety glasses, gloves, and insulated shoes. It also includes ensuring that the system is properly grounded and that all power is turned off before working on any electrical components. Modern phase identification tracers use a variety of technologies to detect the phase signals. Some devices use non-contact inductive coupling, which means that they do not need to be in direct contact with the conductors. Other devices use capacitive coupling, which means that they measure the capacitance between the device and the conductors. Still, other devices use a combination of inductive and capacitive coupling. Choice of technology depends on the specific application and the desired level of accuracy. When using a phase identification tracer, it is important to follow the manufacturer's instructions carefully. This will help to ensure accurate results and prevent damage to the device or the electrical system. It is also important to be aware of the potential hazards of working with energized electrical systems. Always take appropriate safety precautions to avoid electrical shock. In addition to the applications mentioned above, phase identification tracers can also be used for firstly, troubleshooting electrical problems, secondly, verifying the wiring of electrical panels, and thirdly, commissioning new electrical equipment. Phase identification tracers are versatile tools that can be used in a variety of electrical applications. With proper training and safety precautions, they can help electrical technicians and engineers to work more safely and efficiently. Remember to always consult with qualified electrical professionals for specific applications and to ensure compliance with all applicable safety standards and regulations. Electrical work can be dangerous, and it is important to take all necessary precautions to avoid injury. The use of phase identification tracers is just one way to improve safety and efficiency in electrical work. By following proper procedures and using the right tools, electrical technicians and engineers can help to ensure the safe and reliable operation of electrical systems.